Today, Mark and I are back at Ronald Bog Park in Shoreline, Washington. And over there is Ronald Bog.
The pond, not the guy.
Yeah. And so the topic today is propositional logic proofs using the first aid inference rules. So modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, simplification, and so on. So I have placed an argument up here, and Mark is going to solve it. Mark's going to prove it. And can I ask you if you'd discuss your strategy before you even start, Mark?
Sure. I guess if I was first to look at this thing, maybe I wouldn't really see any super pattern right away. I'm just looking at the premises to start with here. I see the two horseshoes. I might initially think hypothetical syllogism, but the B and the D's don't match up kitty corner. Those guys don't match up kitty corner, so that's not going to work. I'm thinking I can't do modus ponens because I don't see a tilde A or tilde or D floating around anywhere. I really can't do a disjunctive syllogism because I would need a tilde A. What I do notice though is I see the tilde A and the D kind of match up here. And that's making me think constructive dilemma. In fact, it does fit the constructive dilemma pattern. So constructive dilemma, if I do that, what I notice is these two make up the antecedents. Constructive dilemma will give me B or H. B, wedge, H. That'd be C, D. This is the rule that uses 3 lines, so I appeal to lines 1, 2, and 3.
And can I jump in here for a...
Go ahead.
Thank you. So let me just outline the CD. This is one of the hardest rules to spot, and students find it difficult to work with at first. So CD says that if you have a P horseshoe, a Q, well, we've got that there, right? And then it says if you have an R, horseshoe, and S, and we got that right there. So we've got P horseshoe, Q, R horseshoe, S. So once you understand the rule, you're looking for that pattern. And then the rule says if you have the P part of this one, and then you have it wedged to the R part of this one, then you're allowed to bring down the Q part of this one wedged to the S part of this one. So the P part wedged to the R part is, of course, right there. And that's why Mark was allowed to bring down the Q part wedged to the S part, which is the B wedged to the H here. And so he brought this down here. That's kind of confusing, but that's the pattern. Looks kind of like a football play, doesn't it?
We're not quite to the goal line yet. We still need to figure out how to get that crazy tilde M.
No.
I don't see any tilde M's anywhere up there. So the only way I'm going to be able to pull this out of thin air is to use addition. The addition rule lets me take any complete line, like B, wedge, H, and then add, with a wedge, anything I want. I'm not pulling it out of here. I just realized I want a tilde M, so I'm pulling tilde M out of thin air using addition from line 4. And there's my conclusion. At that point, we're done. So this is a pretty quick proof. But the first step is probably the hard one to see. I'm kind of hoping the addition might be the easiest. If it would have been a little trickier if this would have been like a tilde B or a tilde D, because then it might look like we need to do something else. But in a way, it was kind of easy because this just isn't found anywhere in the premises, and the only way we're going to get that is with addition. So we're done with that one.
Okay. Can I give you another one?
Sure.
How about this one? We'll draw a little barrier there. You want this one in red?
Sure.
So tilde A wedge B. Oh, you know, does this look like it? A infers Z.
Interesting. Okay, well, here we have a conclusion that doesn't show up in the premises at all. This is telling me a number of things. One, again, I'm going to have to do some addition to bring the Z into the picture. The other thing it's telling me is the premises are almost surely going to be contradictory somehow. There's going to be something in them that there's no way they can be true. Because he's telling me this is a valid argument. I believe him. He's a trustworthy fellow. So if this is valid, And that conclusion just coming out of nowhere, these things must be false. Anyway, it's kind of aside from the point. Let's see what we can do here. First line is my very personal favorite rule, De Morgan's. It fits a De Morgan's pattern perfectly. And I've found with experience, if I see an opportunity to do De Morgan's, I'm going to do De Morgan's. So De Morgan's would give me this. Tilde A, ampersand, a little technical difficulty here. Okay. Tilde A, ampersand, tilde B. From line 1. So with the Morgans, if you're starting off with a wedge, it becomes a ampersand, and if the tilde is outside the parentheses, it ends up next to the individual statements. Okay. Now check out this move. You'll see this occasionally. Let me do a couple steps and I'll explain myself. I'm going to pull out the tilde A, and just hold off on why I'm doing that for a second.
Why are you doing that?
Well, I wanted to write that. No. I've now got an A and a tilde A, which is that kind of the contradiction I was expecting to see. This is the coolest thing in the world. If you can find in your premise, somehow it says A and tilde A, yeah, you know your premises are screwy. There's something wrong with the premises. So it's clearly going to be an unsound argument. But the thing is, if you can get A and tilde A, you can add anything you want to this. So add whatever you want. I want a Z. I'm going to add a Z right there. So that's going to be 2, or add line 2. And now I can use this to do a disjunctive syllogism to get the Z. CS, 4, and 5. So if I know I've got premises that are contradicting themselves, that tells me it's impossible for the premise to be true and the conclusion false. That's impossible because it's impossible for the premises to all be true. So once I saw that the conclusion is coming out of nowhere, I pretty well figured there was going to be some kind of contradiction involved in the premises. And as soon as I see this, I'm thinking, cool, I'll take the affirmative one, add whatever it is I want, then I can do a disjunctive syllogism to get that very thing by itself.
Good. And can I just emphasize the point? I'd like to emphasize the point Mark made that many people find confusing, but I'm just going to reiterate it and kind of make a comment on it. Remember, an argument is valid if it's not possible for the premises to be true and the conclusion to be false. This is a valid argument if it's not possible for the premises to be true and that to be false. Now, since the premises contain a contradiction, they can't both be true, because a contradiction is a statement that can't be true by its very nature. So given that the premises contain or have a contradiction in them, or that they imply a contradiction, it's not possible they're both true. Therefore, as Mark said, it's not possible the premises are true, the conclusion is false. Therefore, the argument is valid. So the general principle is that if a deductive argument has contradictory premises, it's automatically a valid argument. And that seems counterintuitive at first, until you remember that valid doesn't mean true. To say the argument's valid does not say that the argument's premises are true. And as Mark said, in passing, he said obviously it's not a sound argument, it's an unsound argument, but it's certainly valid. But again, valid doesn't mean that the premises are true. This does prove the argument valid.
If you see all that, that's great. On the other hand, if you start doing a proof and weird things seem to happen to your premises, don't worry about it. As long as you're using the rules right, you will be able to get to the conclusion. But it's kind of nice to be able to see what's going on, understand why the weird thing seems to be happening.
Yeah, so that was a little theoretical, but yes, the point is, as long as you reach the conclusion at the bottom, you win. And it doesn't matter, you don't even have to worry about why you win. If you use the rules and get to the conclusion, that's it.
Yep.
Okay, that's it.